Hello and welcome. On the bench today I have the Mechanic CP14 Plus, heating mat, screen remover, screen separator, preheater. You can use it in many ways. Today we're going to unbox it, test it, and basically review it. Now I purchased these as a heating mat, as a screen separator. I have a Microsoft Surface which is not working, which I'd like to try and fix at some point. Unfortunately I'll have to remove the screen. And I also would like to use it as a small preheater for when I'm working on small boards and I want a little bit of heat on the board without having to take out the main preheater, which is pretty chunky. Now I purchased this from AliExpress with my own money, so I'm going to be very honest about this tool. Now let's not waste time, let's open the box to see what's inside. Now this tool is basically a heating mat. There is a heating element inside which should run on mains, and it should be sandwiched between these two look like silicon mats. This runs on mains. In my case it's going to be 240 volts. I think I had to request the 240 volts from the seller. And the idea is that if you are trying to remove the screen from a mobile phone, you place the phone on the heating mat, you turn it to about 80 degrees, the glue around the screen will soften and you can just remove the screen. Now the building is pretty sturdy once this is on a stable surface. It's not wobbly. I don't feel like anything. I mean the silicon mat is very, very sturdy. It's very thick. The whole mat is 8 millimeters, so it's pretty chunky, and I can totally see this is made of two parts. They're probably glued together. Yeah, I can see a little bit of glue. Let me show you. Hopefully you can see the glue between the two layers, the two parts of the silicon mat. And I guess in between there is this mains-driven resistance, which I'm a bit concerned about because you've got mains running inside. Though, again, this is a pretty chunky silicon mat, and I don't want to disassemble this. Again, I purchased this with my own money. I would like to use it, but if I'm assuming that the surface of the mat here is the same thickness of this, let's call it second layer, we're talking about 2.5 millimeters of silicon before your hands end up on mains voltage. Now I see there is a little bit of confusion online when it comes to the measurement of the tool. The actual usable measurement of the tool is 28.5 centimeters by 22.5 centimeters. So yeah, I think it's listed as 35 millimeters, 35 centimeters, but 35 centimeters is the whole tool, including this one, which obviously can't be used. Which, by the way, is kind of disappointing because my surface doesn't fit for literally like half a centimeter, but you know, it's still usable. I think I can still use this tool to remove the screen of the surface, which is not going to happen on this video, by the way. It's going to be another video on the main channel at some point. The back of the unit has this pattern, and I guess is to try and keep the heating resistance as far away from your working desk as much as possible, because one of the concerns I have is that silicon doesn't really conduct heat very well. So obviously, you know, we have 2.5 millimeters of silicon on top of the heating element here. What happens at the bottom, we'll check later on. I mean, is my table going to get damaged when this thing is running for a number of minutes? We'll check with the thermometer and we'll see what happens. At the back of the unit there is a little qualified certificate, which looks genuine though. I think this is an actual stamp, so someone actually stamped it. So I'm hoping that this is telling me that this is a genuine item, but I'm not holding my breath. Yeah, I would say this is probably a genuine stamp. It's leaving ink behind on my cotton pad. So let's turn it on. I haven't myself, so let's turn it on and see what it does. Now the tool comes with a European figure of 8, so I can't really use this one. I'm going to use my UK figure of 8 here. Obviously this tool is not grounded, so we don't have ground issues here, and so nothing to check about. There is actually an interesting feature, which is 2 USB ports for charging. I definitely would like to see how the 5 volts coming out of these ports is derived from mains. I have a bad feeling about that, but maybe, I don't know, maybe I want to put some tape around this. There's no chance that I'm going to charge any of my gear from these USB ports in here, but I'm curious. We'll take a look later on and see how this works inside. Now the box here says this is a 150 watts device, so I'm going to run this through my isolation transformer, so that should give me a little bit of peace of mind. I have a number of fuses around, so nothing nasty should happen. So let's turn it on and see what happens. 3, 2, 1, go. Okay. Yeah, it's reading 19.5, which more or less should be the temperature around here. And I believe this has a timer. So the idea is if you need like 3 minutes for the screen to separate, you just set 3 minutes so it doesn't stay on all the time, which is not a bad idea. Now, I never used this myself. Let me see how it works. Right, okay, so the unit is working. But as you can see, it's reading 80 degrees. I'm keeping my hands on it. It's slowly getting warm. I'm guessing it will take a little while for the heat to pass through the silicon, as I suspected. But it's definitely getting warm. It's just obviously, I guess we'll have to take that indication with a pinch of salt. The sensor is now getting uncomfortable to touch. The sensor is probably stuck where the resistance is and where the heating element is. And obviously, it takes a little while to get to temperature. We'll check in a minute with my laser thermometer, with my thermal camera, with an actual thermocouple, and we'll see what it reads. Now, out of the bat, one thing I'm hearing is that the thing is kind of making this buzzing noise when it's running. I guess it's expected. It's kind of a bit scary because obviously I think there's mains running inside this thing. I don't think there is a powerful transformer inside this little small control panel. Now, I have to say I'm still holding my hands on it and the thing is reading 80 degrees. It's definitely, okay, yes, it's definitely getting hot. I guess it also needs to be pushed down in order to pass the heat out because we got silicon and then I guess you have a little bit of cushion of air inside. I can definitely feel it. And obviously air doesn't conduct heat very well. So you need something to press on the silicon to actually pass the heating out. I guess, if I'm checking with my thermometer here, well, it's reading 67 degrees. So it's not too bad. I guess it depends where I'm reading. But I can definitely feel that if I'm pushing down, it's definitely warmer than if I'm just holding my hand on it. Again, we'll analyze in a minute. Now, let's take a look at this control panel, see how it works. Now, I believe this is now set for run all the time. There's no timer. By tapping the on-off button, basically, I can change the temperature here with a nice little chirpy noise. And what happens then? I just wait and it resumes operation. It's set for 1 minute, yes. So I'd imagine this is going to stop in 1 minute after, I guess 1 minute after it reaches 80 degrees. Let's see what happens. And yes, after 1 minute, the unit turned off. So I guess before it was set to 0, it means forever. And when you have the MIN minutes flashing, it means it's counting. So happy days. But as you might have noticed, I was still holding my hands on top of it. It's definitely getting pretty warm. Don't get me wrong. But yeah, so this is every time you turn it on, it resumes from the previous setup. So that's going to be 80 degrees for 1 minute. And I'm assuming that if I just want to change this, that's my temperature. This is my time. If I set to 0 and I just let it run, oh yeah, I can just push the on-off button again to make it run again. It will run indefinitely, which is not bad. That's it. I mean, this is a very simple device. It just warms things up. Then we should have a light in here. Okay, that's pretty good. It's supposed to be the light to identify and spot dust on your mobile screen, which I'm totally not going to need. Okay, well, it's definitely getting warm. Well, let's see what my thermometer here is saying. Well, it's saying 76. And bear in mind that either a thermal camera or an infrared thermometer, it relies on infrared. And infrared, it really relies on the reflectivity of the material. So on the thermal camera, you can actually set it up, but it's usually set to like a standard value and you hope it's going to be accurate enough. So you always have to take the reading of devices reading infrared with a pinch of salt. Because in theory, you should calibrate the device for the specific device, for the specific material. Now, this is pretty matte, so maybe a thermal camera is going to be pretty accurate. Again, this is reading 77. I think it's set to 80. Here is reading 86. 66 in here, which is not great. 62 down here. Yeah, it's not 58. And I can totally feel that the edges of the mat are basically lukewarm. So the heat is basically focused here in the middle, this area here. And we'll visualize that in a minute with the thermal camera. Now, if I'm using my thermocouple and I'm using a piece of plastic to just hold it down, obviously, I mean, plastic is not the greatest thermal conductor, so it shouldn't really affect the reading too much. But I don't know, my thermocouple is on reading 55 in this area. Let's move it somewhere else. We got 63.4 here. I don't know, random areas here. 64 here and 63 here. And my infrared thermometer is reading, my infrared thermometer is reading something completely different. It's reading 78, 71, 78, 70 here, 73 here. The thing is, I mean, if this was 80 degrees, I don't think I would be able to keep my hand. I mean, it's getting uncomfortable, but 80 degrees, okay, now it's pretty... I mean, I could keep my hand a moment ago, now I can't anymore. But I don't think this is 80 degrees uncomfortable, so I'm not entirely sure how I can actually accurately measure the temperature of this plastic pad. If you like my videos, I'd like to ask you a favor. I would like to upgrade the front-facing camera I'm using for my videos. I'm currently using my iPad and the front camera of the iPad, which is not great. So I'd like to upgrade the image quality from this to this. And to do that, I'd like to purchase a Sony E10, which is the same camera I'm using for the overhead. If you would like to help me with that, I set up a GoFundMe page. The link is down below in the description. So take a look at what I'd like to do. And if you don't want to donate, it's totally fine. I hope you're enjoying the video. And in fact, I've been talking too much. So let's go back to the video. Now, my thermal camera is showing something quite interesting. It looks like it's able to show the actual heating element, which is much finer than I suspected. This is really, really interesting. Now, unfortunately, we do have patches of heat, and we got 80 degrees here, but everything else here is 65. Let's see if I can add some other points. You might be able to see in this area we have like around 70. P3 is definitely the warmest area, and it's probably where the temperature sensor is. I mean, this is probably not great. Now, what happens if I... Of course, now you can see... Okay, I actually feel something here underneath. So that's probably where the temperature sensor is located. But then I don't understand why this area here is warmer than anything else. I mean, that being said, according to my thermal camera, I mean, the temperatures are not very accurate. Fair enough, but not too far away, considering these 3 points are between 73 and 76. The center part is the coolest. And this is where the mat is actually ending. So there is this area here, which is not heated at all. So you can't really use the whole mat. The heating element starts, say, a centimeter inside the heating mat itself. But this camera is actually amazing. It's my new Thermomaster P3 that was sent to me by Thermomaster. So this is technically a sponsored message. But I really like it. It has this amazing resolution, allows you to see things you couldn't really see with other cameras. Now, I have a feeling that once you have an item pushing on the heating mat, like a mobile screen or an iPad or a Surface, then these unevenness in temperature might mitigate or disappear altogether. I have a feeling that this is due to some little pockets of air inside, because I can definitely see, especially when I'm bending it, I don't want to bend it now, which is energized, but when I'm bending it, I can definitely see this is not completely glued. The idea is this can be flexible. So I have a feeling if you have a little bit of air, even like 0.5 millimeter of air, this is a big insulator, and that will account probably for those 20 degrees that we see of temperature difference around the mat. By the way, my watt meter is measuring 190 watts when the heating element is energized, so clearly this is not 150, but it's 190, just to bear in mind. Now, one thing I'd like to try with the tool is what is the maximum temperature that it can reach. So I guess I'll have to push this button, yeah, and I can go up to wherever it goes. 120, okay. This is also set to 0 minutes, so it should go on indefinitely. Let's see, let's hope nothing really happens. Let me turn on my thermal camera again. Now the screen remover is now getting to 120 degrees, and I can see the pockets of air I was talking about, so the materials are deforming a little bit. And let's see what my thermal camera is saying. Well, thermal camera is reading 98 degrees in the hottest area and 85 in the center. But once again, I have a feeling that this is mainly due to these pockets of air. I'm not entirely sure about that. Now, assuming you're going to use this tool at its maximum temperature of 120 degrees, I'm reading with my thermocouple, so this should actually be an actual temperature, 64 degrees and rising under the tool under the mat, so you definitely want to make sure that you have some protection. 67 degrees rising is probably not what you'd expect. That being said, I guess you wouldn't normally use this 120 degrees, but if you do, just remember that you might need some protection underneath. Yes, so it's definitely getting pretty toasty under my desk in here. I'm sticking my hand under my other silicone gray mat, and it's getting really, really toasty, so I might want to lower the temperature, and for the future I might need to remember I need something else in between. Now I just placed 3 random empty PCBs on the mat and see if that makes any difference, because there's not much pressure going down. I see the right PCB here is not completely flat with the mat because of this little bump. I'm assuming it's the temperature sensor located around here. I set the mat to 90 degrees as it looked like it was more or less 10 degrees off, or say on average. And with my infrared thermometer, I'm actually reading 86 here, 87, 88 here, 86 here, 82 here, 83 here, 82, 80 here, 80, 84, this one is 85, 79, and 84. Well, so it looks okay, though this is a shiny surface, as I said before. The infrared thermometer needs to be taken with a pinch of salt. And indeed, if I'm reading with my thermal camera, the situation seems to be improved, as there's no huge difference between the red area and the blue area. Remember, the thermal camera will always maximize whatever delta it has, so the blue is always the lowest temperature and the red is the highest, but it could be 5 degrees, it could be 50 degrees. So in this case, between these P1 and P2, I have 72 versus 79. This point here is 74. This one is now 75, and this one is 75. So it's pretty accurate. So I believe my idea that you need something on top to mitigate the unevenness of temperature is probably correct. Also, these act as basically heat spreaders, like the ones that you find on CPUs. So the bottom line is, it doesn't seem to be too bad. And if I'm using a thermocouple in between the PCB and the mat itself, which I believe is the most reliable way because it doesn't rely on reflectivity and infrared at all, if I'm pushing with a Q-tip to try not to suck away the heat from the PCB itself, it's actually reading 88 degrees, which is very, very close to the 90 degrees I'm setting the tool to. So maybe we can actually be pretty happy with this tool. But please do remember that even with the tool at 90 degrees, which is more or less the ones that you're going to use when you're separating screens, under the mat, you're going to have 77.6 degrees. I can totally feel my desk getting warm below the desk, under the desk. So you definitely want to have some sort of extra insulation, unless you're using for a few minutes. That's probably going to be a big deal. Well, it looks like to turn this off, it's not the on-off button. The on-off button is only for changing settings. So my only way to turn this off is going to be from the switch, which is not the end of the world. I guess we got some capacitors, yes. Let's quickly check what kind of voltage we're getting from the USB ports. And then we'll open it up and we'll see how it's made. And we get 4.92 volts. I had to use this very long extension. That's probably why the voltage is a bit low. Otherwise, the screen would face down. We'll take a look inside how this is actually generate. I have a bad feeling about that. Well, we'll find out. Little nice feature of the CP14 is this area is slightly magnetized, not a lot, but the screws are not rolling away, and you have a little space for your tools. Oh, okay. We can't open it without removing those things. Okay. And I have to say, I'm quite surprised. I was not expecting this. I was expecting like a bunch of wires, 3-4 components all stuck together with some glue, and like a big resistor for the 5 volts coming straight from mains. But no, this I feel is nicely done. I'm happy with it. Now mains is coming through here, one leg is going straight to the PCB here, the other one is going through the switch, is changing color and coming back to the PCB as well. So we got mains coming here to the PCB, and neutral, well, this is a figure of 8, so you can swap it, but let's call it neutral, the black wire, is going straight to this connector here. And this connector here is wired to the heating element, which you can clearly see right now. It looks exactly as it looked on the thermal camera. That thermal camera is absolutely amazing. Thank you very much, Thermal Master, for sending it, by the way. I'm really impressed. And as you might have been able to see, there is a little thermocouple that came out that was just placed here, which is going to be under the heating element for whatever reason. That's the bump that I could feel on the right-hand side, which is on the left-hand side. This is on the other way around, on the other side. Now, the heating element is driven by this component here. This is a triac. I had a look online. I could find the data sheet of this one. I couldn't find most of the data sheets of all the other components, even though the components are not wiped, then they haven't been erased, but I couldn't find anything online, or very, very little. But this is definitely a triac. The triac is driven through an optocoupler by this little chip here. This is a PIC. I'd imagine that's where the software is, the little logic, the little control panel logic behind the tool. This is the LCD driver for the LCD. And this little chip in here, according to Google, is the touch sensor. So the PIC is driving the triac through an optocoupler, so that's a nice touch. The heating element is connected to the PCB via a connector. And again, that's a nice touch. And here, you might be able to see a bridge rectifier. So we got mains, which is being rectified. Then we have DC, and we have a big bull capacitor. The bull capacitor is going through a small switch and mode power supply. So no nastiness in here. It's very simple, but it's fine. I'd imagine this is the controller. I couldn't find anything online about it. And then we have a little bit of rectification, a big diode, a big capacitor. So we're going to have, I'd imagine we have like some sort of DC voltage coming here, which is driving the PIC, the LCD driver, the touch controller, all the logic ICs. And that DC voltage is also driving this section of the board here where the USB ports are. And this is a DC to DC converter. So it's a proper converter. It's nothing nasty. We have an inductor, and then we have 5 volts going into the USB ports, and also the beeper. So I would say this is pretty elegant. I wasn't expecting anything like this. I think I paid this tool £40, 42, something like that. Was that $50? For $50 shipped, I was totally expecting something extremely dangerous in here. I was expecting to have to redo something. I have to fix something. This is pretty nice, to be honest. I think for this kind of tool, I'm definitely happy to use this tool. There's no ground, of course. This is how the tool is designed. It's totally fine. There's nothing metallic. Everything is plastic, so it's totally fine not to have ground. If I want to be really fussy, a couple of things. Number one, in this area here, you have low voltage. You have 5 volts going to the USB ports. In this area here, you have mains. Not on this trace here. This is where the control for the triac is coming from the PIC up there, but the control line is going into the triac has mains voltage, so I was expecting, there is separation, don't get me wrong, with 3-4 millimeters. I was maybe expecting a cut or a bit more separation if you want to think about it. There is a cut between the live and neutral of the bridge rectifier. You know, you're plugging your mobile in here and a few millimeters away you got 240 volts, but there is some separation, so it's not horribly wrong. And the other thing is that it would have been nice to have a fuse on this board. You got mains coming in, something happens. I mean, in the UK, we have fuses inside the plugs, so I'll make sure I have the smallest possible fuse for this tool, so it's as safe as possible. It would have been nice to have a little fuse somewhere. Why not? Now, I'd imagine there's really nothing on the other side of the board. I really don't want to remove it, and the reason is where mains is coming in. And by the way, all the fasteners are all insulated, so that's another little touch. This whole assembly is attached with a couple of clips, but you have clips at the bottom as well. And I can definitely push this too, push the assembly out, but then I would need to push the clips which are at the bottom, which are completely inaccessible. I'd imagine this has been plugged after the board has been installed. I mean, if you need to replace it, if you need to do some repair, probably there is a way to do it. I just don't want to do it now because it looks like a potentially destructive process, let's put it that way. Now, I'm curious to see what kind of voltage comes out of this power supply, and while I was looking at the PCB, I think I understood a few more things. Now, I managed to find the data sheet of that little IC, and it's definitely an online switcher, so it's getting mains, it's got the MOSFET included in it, and it's working with a little transformer, the diode, the capacitor to provide some kind of voltage. And I'd be curious, number one, to see what kind of voltage that is. Then I realized that the output of this circuit is following this trace here, this chunky trace here, And one end of the trace is going to the DC to DC converter here for the 5 volts output for the USB, and it's pin number 6. The input is pin number 6. There we go. The other end is going through, there's a 4.7 ohm resistor here. So one end of the resistor is getting the voltage coming out of the transformer, and the other end is going to this little component. It's got a 3.3 in it, so I'm assuming this might be a 3.3 volts regulation. I don't know. All I know is that this leg, which might be the output of the voltage regulator, is going to the electronics here. And this is going to the input of the LCD driver and also the input of the PIC. I'm just curious to see what kind of voltage comes out of this and what kind of voltage maybe comes out of the voltage regulator. Now, I've got this already preset to like 18 degrees, so it will turn on, but the heating element is not going to be energized. And I'm going through an isolation transformer for added security. So let's turn this on. 3, 2, 1, go. Okay, so I'm probing here at the 4.7 ohm resistor. Okay, we're getting 15 volts. So yeah, 15 volts, and then it's being stepped down by the DC to DC converter to 5 volts. And what kind of voltage are we getting out of that little regulator? So I'm going to probe here on this capacitor. Are we getting 3.3? So yeah, the 3.3 on the regulator is definitely an indication that it's a 3.3 volts regulation. So pretty simple, 15 volts out of the power supply going into 2 different directions. In here is being stepped down to 5 volts for the USB ports, and in here is stepped down, well, it's regulated to 3.3 volts for the rest of the electronics. And that's it. So this is pretty cool. Let me reassemble it and I'll give you my conclusions. Now, I do have another little concern about this product, and it's about the temperature sensor. I found it stuck in there, in between the heating element and the silicon mat. And number one, it would have been nice to have a little recess maybe, so it can stay there without making a bump at the top, but that's not the problem. Number one, depending on where this is going, it could be very, very close to one of those traces or in between two. So I guess there might gonna be quite a difference in temperature depending on where this is going. I have no way to control it. Maybe I could use some Kapton tape. I think I'll just leave it as I found it. The other thing is again, there's mains running through this heating element, and there's not much insulation between mains and the thermocouple itself. So anything happens over time, you might get mains through the thermocouple, which will probably destroy the microcontroller. It's probably not going to affect you. We'll see some smoke coming out of the unit, but maybe that's not the best design. So what's my final opinion on the Mechanic CP14 Plus? Well, number one, I'm pleased on how it's made. The electronics seems to be okay, nothing horribly dangerous inside, so this looks like safe to use. It's all made of plastic, it's all enclosed inside silicone and plastic, so should be safe even though it's not grounded. Now you have to remember that you've got mains running under the silicon mat, so you need to pay attention with your multimeter probes, for example, because if you pierce through the silicon mat, well, you'll get in touch with mains. So make sure you have an RCD on your electrical system, or with everything, to be honest, not just with this mechanic tool. And maybe you want to make sure you have a fuse. I would say a 3 amp fuse for 240 volts users should be enough. Now for screen separation, I think this is working totally fine. Now if you're planning to use this as a simple preheater, maybe that's not the tool you're looking for. And the reason is that this tool seems to be able to transfer heat via contact, not via infrared. So when earlier on I placed a flat PCB on this tool, they actually got to the temperature required, but now I put a random PCB, it's an old CPU, which has components at the back, so the PCB is not really touching the tool, and yeah, eventually gets kind of warm, but it's reading 45 degrees and the tool is set to 80 degrees. Yeah, the temperature reading is a bit all over the place, but the thing is, I don't think this, it might help, but I don't think this is gonna work, or it's the best tool for preheating a board that you want to solder on or do rebolling or that kind of stuff. For that, you need something that can irradiate heat. I can't really feel this 80 degrees from here. I need to put my hand on top. And finally, remember that the back of the unit is getting more or less as hot as the top, maybe some degrees less than the top, but you definitely want to have some protection for your desk, whatever desk you're using. I believe I paid this tool £40, so say $50 shipped, and I'm pretty happy with it, with what it's delivering. It might not be the preheater I had in mind to replace my chunky one for when I'm doing small jobs, but for what it's supposed to be doing, screen separation, I think it's probably working totally fine. Keep an eye on the main channel. I will eventually end up using this tool to remove the screen from my broken Surface. And if you enjoyed this video, I would really appreciate a thumb up down below, and also consider subscribing to this channel and my main channel if you like this kind of things. Don't forget I'm on Patreon and on Facebook, and the links are also down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to support me on Patreon, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, well, I hope you enjoyed the video. I wish you a great day, thank you for watching, and I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye. Bye-bye.